Hey there, chemistry students. This is Miss Ruark. This is vodcast 9.2. We're going to learn about pH and pOH. Okay, before we get into what pH and pOH are, we need to talk about different properties of acids and bases. So how can we tell the difference between an acid and a base? Well, an acid is going to taste sour. An acid, if you get it into a cut, it's going to have a sharp stinging pain that is associated with it. Acids will react with metals. And we call acids proton donors because they give off hydrogens. They have a high concentration of hydronium ions or hydrogen ions. Remember, those are the same. And the range on the pH scale goes from about 0 to 6, give or take. You can go higher than that if you wanted to say 7 or, but 7 is pretty neutral, so 0 to 6. If you have a pH of 0 or 1, it's going to be the strongest acid, and then our weakest acid would be around a pH of 6. Okay, bases, on the other hand, have a bitter taste to them. They don't taste sour, they taste bitter. Okay, yuck. They feel slippery to the touch. Okay, think about what soap feels like. Okay, base. These can dissolve organic matter. Organic matter is just something that's carbon-based. Okay, and protons, excuse me, acids are called proton donors, whereas bases are called proton acceptors because they take on hydrogens. They have a high concentration of hydroxide ions, and the range for pH, or for the pH for base on the pH scale would be from about an 8 to a 14. Your strongest base would be around a pH of 14, and your weakest base would be around a pH of 8, give or take. All right, well, what about water? We all know that water is neutral. Water has a pH of 7, and water is something that we call amphoteric. Okay. If it's amphoteric, that means that it can behave as a base or as an acid. It just depends on the nature of what it's reacting with. So if you take HCl and you stick it with water, in this case, the HCl would be your acid, so the water behaves as a base. Well, what if we were to take water and put it with sodium hydroxide? Okay, in this case, we know that this is our base, so the water has to be an acid. So it depends on what it's placed with. All right, in an acid-base reaction, we've seen these before. Nothing new here. An acid-base reaction is also called a neutralization reaction. And we know that an acid-base reaction is when an acid reacts with a base, and it will form water and a salt. Now remember, this isn't just table salt, this is a salt. Excuse me, which means that it's an ionic compound. Okay, acids and bases will also form what we call hydronium ions, H3O+, and hydroxide ions, OH-. Okay, and these ions are also going to be formed by water. Water can self-ionize. So water, we've seen this before, water can actually break down into hydronium ions and hydroxide ions. And we would need 2 waters to make a hydronium ion and a hydroxide ion. One of the waters would act as a acid, and the other one would act as a base. We would use this self-ionization of water to give us our Kw value. Now our Kw value is the ionization constant of water, and the Kw value is 1.0 times 10 to the negative 14th, and that's the concentration or the molarity. Okay, so we can use this number along with the concentration of these in an equation. So we know that Kw is equal to the concentration of hydrogen ions or hydronium ions, same thing, times the concentration of hydroxide ions. These two multiplied by each other should give us the Kw, which is a constant, and it remains the same all the time. So multiply those two together, you should always get 1.0 times 10 to the negative 14th. If you have the hydronium ion concentration, and you want to know the hydroxide ion concentration, you can plug it into this equation and solve for the one that you're missing. Okay, which is what we're going to do right here. So it says to determine the hydronium and hydroxide ion concentrations in a solution of 3.0 times 10 to the negative 2 molar NaOH. All right, well, to solve this, first we need to figure out, is NaOH an acid or a base? It is a base. We know it's a base because it has the hydroxide. Okay, well, is it weak or is it strong? The group metals is going to be a strong base. And remember, strong bases will completely break apart into the ions that form them. So NaOH will break down into Na with a positive charge and OH with a negative charge. Before we go any further, we want to make sure that it's balanced, which it is. Okay, and so our balanced equation, or mole ratio of NaOH to OH, would be a 1 mole to 1 mole ratio. All right, balanced equations give us our mole ratios. All right, so if I have a concentration here of 3.0 times 10 to the negative 2, well, we know that 3.0 times 10 to the negative 2 m is the same thing as saying 3.0 to the negative 2 moles per 1 liter of solution. How do we know that? Because this m right here is moles per 1 liter of solution. So all we did was change the units, and now we have a mole value for our sodium hydroxide. So we have 3.0 times 10 to the negative 2 moles of sodium hydroxide. Okay, well, how many hydroxide ions does that leave me with? Well, we use our mole ratio here. We know that 1 mole of sodium hydroxide contains 1 mole of hydroxide ions. And so we can do our math, and we end up with 3.0 times 10 to the negative 2 as our concentration of the hydroxide ions. So we've just answered the first part, or the second part, however you want to look at it, of our problem here. We said our hydroxide ion concentration is that right there. Well, I still want to know the hydronium ion concentration. So to find that, we would plug it into Kw is equal to hydronium ion concentration times the hydroxide ion concentration. We know that Kw is 1.0 times 10 to the negative 14th. We know that we're looking for our hydronium ion concentration, so we don't have that. And we know that our hydroxide ion concentration is 3.0 times 10 to the negative 2. Okay, so all we have to do is get H3O plus by itself. How do we do that? We divide both sides by 3.0 times 10 to the negative 2, and that happens on both sides. Cancels here. So my hydronium ion concentration is equal to the calculator tells me 3.33 times 10 to the negative 13th. And remember, it's a concentration, so we need to have our units for concentration in there. So there's the answer for one, and there's the answer for the other. All right. And you can use that anytime you need to know concentrations. All right, when we do an acid-base calculation, we need to know certain things. So we just learned about Kw and how Kw relates to hydronium ion and hydroxide ion concentrations. So let's look at some more stuff. In a neutral solution, molar concentrations of hydrogen or hydronium ion and hydroxide ion are going to be equal. This is in a neutral solution. In water, which is a neutral solution, the concentration of both is equal to 1.0 times 10 to the negative 7th molarity. In another solution, when the hydronium or the hydrogen ion concentration increases, the hydroxide ion concentration will decrease, and vice versa. That should be a C. And vice versa, which means that as one goes up, the other goes down. So if the hydroxide goes up, the hydronium will go down. When there's more hydronium or hydrogen ions in the solution, it is acidic. And when there's more of the hydroxide, it is a basic solution. I'll review. Okay, using the pH scale, we do calculations using the pH scale. pH would be the power of hydronium ions or hydrogen ions. We know that when the pH is 7, it is a neutral solution. And if it's a neutral solution, the concentration of hydrogen ions is equal to 1 times 10 to the negative 7th. If our pH is less than 7, it's going to be an acidic solution. and our hydrogen ion concentration is going to be greater than 1 times 10 to the negative 7th. When our pH is greater than 7, it is a basic solution, and our hydrogen ion concentration will be less than 1.0 times 10 to the 7th. Okay. The equation that we use to solve for pH is negative log times the hydrogen ion concentration. So if you want to solve for pH, you have to have the hydrogen ion concentration, and you're going to plug it into your calculator. And each calculator is different, so double check your work, and if you can't get the answers, come and bring me your calculator so I can help you find it. Okay, because the different calculators work different ways. Okay, we have a pH, which is the hydrogen ion concentration. We can also have a pOH, which is your hydroxide ion concentration. It's the same equation, except pOH is the negative log of hydroxide ions, whereas pH is the negative log of hydrogen ions. Right, so if I give you the hydrogen ion concentration, you can solve for pH. If I give you the hydroxide ion concentration, you can solve for pOH. Now, we also remember that Kw is equal to the hydronium ion concentration times the hydroxide ion concentration. So all of these things can be used to go back and forth from one to the other. Okay, and then we also have one more helpful tool, which is this very last part here. Right? We said that this is 1.0 times 10 to the negative 14th. That's what Kw is, right? Well, if we took the log of that, it would be equal to 14. So we can say that pH plus pOH should be equal to 14, since this times this equals that. Okay, so it's the same thing, it's just a different way of looking at it. All right, so how can we use all this? Well, number 1 says to calculate the pH if the hydrogen ion concentration is equal to 3.4 times 10 to the negative 5th molarity. Well, we know that we're looking for pH, and pH is equal to the negative log of the hydrogen ion concentration. Since we have a hydrogen ion concentration, we're going to take that number and plug it right in. Okay, so to get our pH, we do the negative log of 3.4 times 10 to the negative 5th. Okay, all you have to do is plug that into your calculator. Okay, and this is where I want you to check to make sure that it comes up right, and if you don't get the right answers, then double check with me so I can help you. But your pH should end up being 4.47. Okay, and that's your pH. Now pH doesn't have any units, it's just pH, so that would be your answer. Okay, for problem number 2, it says determine the pH of a 2.0 times 10 to the negative 2 molar strontium hydroxide solution. So they want to know the pH of this solution. We need the negative log of the hydrogen ion concentration. Okay, we need hydrogen ion concentration, and here they give us SrOH2. Now the problem is that this is a base. And if you remember, it's a strong base, which means that if it's a strong base, it's going to completely dissociate into strontium ions and 2 hydroxide ions. Okay? We know that we have 2.0 times 10 to the negative 2 moles of strontium hydroxide. So let's figure out how many moles of hydroxide ion we have. Well, we know that the mole ratio here is a 1 to 2 ratio. And so when we do our math here, that ends up giving us a hydroxide ion concentration of 4.0 times 10 to the negative 2 per 1 liter, which is the same thing as molarity. And this is for our hydroxide ions. You have 2 ways you can solve this. One of them is you can use the Kw, okay, and you can plug this in and solve for the hydrogen ion concentration and then get your negative log. Or the other way you can do it is you can solve for pOH by doing the negative log of the hydroxide ion concentration, okay, which is the one I'm going to do, because you've already seen this one. You haven't seen this one. So on this one, we would do the negative log of 4.0 times 10 to the negative 2 molarity, which ends up giving us 1.40. And then to get our pH, we use this equation here. And we plug this in for our pOH. So 14 minus 1.40 gives us 12.6. And there's your answer. Okay. And then problem number 3, I'm not going to have time to do, but when you come to class, if you have questions, I will show you. You have to do the anti-log. Okay, I'll see you in class, guys.